ratio test. Okay, so here's the ratio test and what is necessary for us to make it happen. So we have a series. It has to be an infinite series. So if this series converges if we take the limit of the n plus 1 term over the n term, absolute value of that, if that is less than 1, then this series up here is going to converge. Likewise, if it is greater than 1 or does not exist, then it will diverge. The ratio test is inconclusive, which means you would have to attempt a different approach, a different test, if the limit is equal to 1. You're going to use this one quite often, so you want to make sure you have it down in the practices quite a lot. We use this technique for helping us find many other things too, like the interval of convergence and stuff like that. So we want to make sure that we know how to do this one. This is a very important one. So let's look at some examples and we'll go from there. Determine the convergence or divergence of the following. So here's our first series. Okay, so the first thing you want to do, okay, well that's our series, so then we want to, what is a sub n? A sub n is that, I'm sorry, let's do a sub n plus 1, so you can see how that's done. So all you do is you just take whatever n is and put a plus 1 there. So then this is going to be 2 to the n plus 1 over n plus 1 factorial. So that's how you determine those. So then once I have that, the limit as n goes to infinity, absolute value, the n plus 1 term divided by the a sub n term. And I want to put a 2 there. So this is the absolute value of all that. So as we clean it up, and you can, a lot of times you can always write this step first, in my opinion, because it tells everybody that you know what you're doing, you know the rule, and then from here, then you just kind of flip the bottom and multiply. We're looking for ways to reduce this. So there may be some techniques in here that will help you understand how that works. Okay, so the next step here is to look at this and say, okay, well, how do I simplify this down? Well, this is 2 to the n plus 1, which basically means it is 2 to the n plus 1 is 2 to the n times 2 to the 1. Okay, because you add exponents. So that means, if I look at it in that sense, this 2 to the n is going to reduce with that one, and it's just going to leave me a 2 up here. Okay, now what about the factorial thing? Okay, well, factorial, remember, simply means that number times every integer from there going down to 1. So n plus 1 factorial means n plus 1 times n minus 1 all the way down to 1. Well, that right there is just n factorial. So that means I only have the n plus 1 left on the bottom. So what is the limit as n goes to infinity of this expression right here? Well, that's equal to 0. And since that number is less than 1, then I know what? So by the ratio test, this series converges. And there you go. Okay, let's look at the next example down here. Same thing. If it helps you out, you can go ahead and write that out, what a sub n plus 1 is. Okay, doesn't hurt to do it. This will be n plus 1 squared times 2. N plus 1 is n plus 2. And this is 3 to the n plus 1. So that's what we have there. Take that expression and divide it by that expression in this limit. Over 3 to the n plus 1 divided by and we need to simplify that. And at this point, you usually write it like this, to the n plus 2, and then you flip this over here, and you start reducing or simplifying some things out. Okay, so what happens as we go through all this stuff here? Again, this is 3 to the n times 3 to the 1, so the 3 to the n's will drop out. This right here is, there's one more 2 up here than there is down here, okay? And then you look at this stuff in here, is there something that we can do with this, or we just leave it? So this right here, if I simplify it all out, can give me something that looks like this. 2, here's the n plus 1 squared, I'll just leave it up on top. Down below, I'll have a 3 and an n squared here. Now, this is just a polynomial, so if I multiply everything out up here, I'm going to get 2 to the n, 2n squared, and then this 3n squared. So at infinity, those are the only things that matter. So this thing here equals 2/3. And so that is less than 1. And so once again, I know by the ratio test that the original of n squared 2 to the n plus 1 over 3 to the n converges. And that's how that works. Okay, so if you have any questions about how I got and worked this out, just make sure you ask. I have one more example for this on the right here. Oops, there it is. So here we go. What is our n plus 1 term? N plus 1 to the n plus 1 over n plus 1 factorial. All right, so here we go. And so I have plus 1 to the n plus 1 over n plus 1 factorial, n to the n over n factorial, and then here is n factorial, n to the n. Okay, so what is all this going to become besides an ugly looking mess? Let's see. What can I do here? Well, I know that this and this can reduce out. I don't know so much about this over here, but we can clean it up just a little bit. So this right here is this to the n plus 1. Okay, which so the same idea as before, even though with this was a number, I can rewrite this right here as n plus 1 to the n times n plus 1. There's my n factorial. This right here I can write as n plus 1 times n factorial times n to the n. And so you'll notice some things going to drop, all these will drop out right here, and I'm left with the limit as n goes to infinity of n plus 1 to the n over n to the n. And so then I can rewrite this as the limit as n goes to infinity, because they're both to the n power. I can write it as n plus 1 over n to the nth power. Now, what's so unique about that one? Okay, well, believe it or not, it's the actual definition of E. Okay, so something to think about there. And so what is E? 2.78 and some change. That continues on forever. Since this is bigger than 1, what does that tell me? Well, by the ratio test, the original series of n to the n over n factorial diverges. Okay, so that's how it works. Here's a little side note at the end. The ratio test is a powerful tool to determine convergence of more complicated series. We will use this test to find intervals of convergence for power series, which is coming up soon. So if you have any questions about this technique, please let me know.